Hey guys, welcome back to my channel. In today's video, we'll be learning about a math topic, which is basic connectivities and truth tables and logics. So in this presentation, we'll be exploring about the logical connectivities, which you might know, the AND operation, operator, or not. So here they act as logical connectivities, which is AND or not. Then the implication and biconditional. We'll see how to construct and interrupt in truth table, as this work as powerful tool for analyzing the behavior of logical expression. Without wasting any time, let's get started. Logical connectivities. The logical connectivities are the basic operators in maths logic and computer science used to combine and manipulate logical statements. So why do we need this logical and connectivities is because the logical connectivity makes us understand the formal logic, which is used for building this digital circuits and also developing different software applications. Now, what are the commonly used uh, uh, logical connectivities are basically the and, or, and not. As you can see, the symbol name the and operator itself has so many symbol names and symbols, also the or and not. So and or not, and we also have new ones which are implication and biconditional. Let's study deeply about them, starting with the and connectivity. So this and connectivity is also known as conjunction. Its definition says that the and connectivity is true if and only if both the operand are true. Basically, it says that if both the operands are true, then only it will give the truth value. As you can see, if even if the one operand comes as false, it comes as false. So basically, it says that if any one of the operand is false, then the connectivity says that it will be false. As you can see, true and true gives us true value. True and false gives us false. False and true gives us false. False and false gives us false. Now, in this maths basic connectivity, the symbol we use for AND operator and connectivity is the upper arrow mark. Now, let's see about the OR connectivity. OR connectivity is also known as disjunction. It defines as the OR connectivity is true if at least one of the operand is true. It is quite opposite to the AND operator. As you can see, even if one of the operand comes as true, the value comes as true. True or true gives us true. True or false gives us true. False or true gives us true. And false or false obviously will give us false. And here the symbol we use for OR connectivity is downwards arrow. Now let's see about the NOT connectivity, which is negation. Here the symbol we use is kind of a line, and it defines itself as the not connective is true if the operand is false and false if the operand is true. So here we have basically two operands, only one operand, and if it gives the true value, it gives the not value gives as false. If the input is false, then the not value gives us true. Now let's learn about the implication connective, which is also known as the conditional. It defines itself as that the implication connective is true if the first operand implies the second operand. So let's know about this better by seeing the truth table. As you can see, we have two operands with implication connectivity. So the true and true gave us true. The false and true gave us true. The false and false also gave us true. But the true and false gave us false. So it says that the first operand implies the second operand. So basically, the one which implies the second operand will give us the true value. So the true false gives us the false. It is symbolized with an right side arrow mark. So we need to practice this truth table. Now the last one is the biconditional connective, which is also called as only biconditional. The biconditional connective says that it is true if the both operands are either true or false. So let's learn about this with the truth table. Here we have two operands. True and true gives us true. True and false gives us false. False and true gives us false. The false and false give us true. So basically the operands which are same gives us true values and operands which are different give us false value. The symbol is double side arrow mark, which is quite easy. This one is quite easy to learn. Meanwhile, the implication is quite difficult. So now let's see their application, the complex logical expressions. So combining the connectives, logical expressions can be combined multiple connectivities which create more complex statements. For example, as you can see here, we have used P and Q or not R. So which is quite complex. The truth tables, the construction of truth table for complex expression helps to analyze their behavior. So how we analyze this logical expression is firstly combining those connectivities, then writing them as we have shown in the example, and then analyzing their truth table. As you can see here using this diagram, also the each connectivities have their own circuit diagrams. As you can see, this one is for the or expression. This one is for the or. This one is for the and. So here we have derived an truth table using and, or, and not. Let's move on to the next topic, which is the applications. So basically, where we use this logical uh, connectivities is basically in the real world application. Of course, the logical connectivities are fundamental for computer science, also digital electronics and maths, which enable them to design complex systems and algorithms. So the key takeaways, the second one is the key takeaways. Mastering these logical connectivities and truth table helps them to provide a solid foundation for further studies in logics for either for computer programming or mathematical reasoning. And why this is important to understand is basically proficiency with logical uh, connectivities and truth table is essential for success in logic based courses and also problem solving in computer science engineering. So by this, I'd like to end my video. Thank you so much for watching.